Hi everyone, welcome to my presentation. In this video, I'm going to teach you some basic fundamentals of object-oriented programming. So in this presentation, we will talk about some basic overview of object-oriented programming, like Java classes and objects, encapsulation, and method overloading. And lastly, we will talk about the constructor method and this keyword. So what is an object-oriented programming? An object-oriented programming is a concept used in programming languages that align with human thinking, such as how we think and interact with others in real world. So in programming languages, we use the objects to represent real world and then use the object relationship to describe how these things behave or interconnected. So there are two types of programming paradigm. The first one is the process oriented, in which we are trying to analyze the steps required to solve a problem. So we combine these steps in form of function or methods and then call these steps in sequence to solve a problem. But in comparison to this, object-oriented programming divides a problem into separate objects, where each object has certain rules and behavior. We can invoke these rules by calling object methods to solve the problem. In this way, object-oriented programming reduces the complexity of the problem by dividing the problem into different and separate objects. So there are three main characteristics of object-oriented programming. The first one is encapsulation, the second one is inheritance, and the last one is polymorphism. Encapsulation is the core concept of object-oriented programming. The idea behind encapsulation is to hide the implementation of the class. So if we want to access some information or some methods or variables from the class, we can only access them using public methods. We cannot access them the private information. So in this way, we are actually hiding the implementation details from the outside world. In inheritance, we are trying to use a code which are already defined in previous class. For example, we have two classes. One class have some methods and second class also have some methods. But the second class need to inherit some method from the other class. So instead of rewriting the code, we are actually reuse code from other class by using inheritance. And lastly, the polymorphism refers to attributes and methods of a class inherited by other classes. So this means if we have created an object of parent class and there is a common method between parent class and subclasses. So whenever we refer one subclass to a parent class object, each method will behave differently. So this type of behavior is called polymorphism. So what is the relationship between a class and object? So basically, an object is an instance of the class. Object-oriented programming aims to model the real world by using the classes and objects. So a class can be used as a template or an abstract description for a certain type of things. And then if you want to represent a specific instance of that type of thing, we can use them as an object. To further clarify, let's see this example in which we have a person class and we have four objects. So person is a category which have certain set of behavior, and so we can represent different set of behavior as one. So we can create a class of a person. So a person can be a woman, a person can be a man. Each person have different name. So we can identify individual person by creating an object of the person class. Here, the class with the template is a person which have certain characteristics where each individual is the object or instance of that class. So to create an object, first we need to define a class. As we discussed in previous slide, that class is an abstract view, a template of the objects. So each class have certain characteristics. For example, in person example, a person have a name, a person has an age and gender, and they have some other characteristics for such as a person is working or doing shopping or maybe any other behavior a person can perform. So in object-oriented programming, we can encapsulate these shared characteristics of the specific classes. For instance, the common attributes can be represented by member variables and common behavior can be represented by member methods of the class. So in this slide, I am going to teach you how to define a class using syntax. So in the class, the first one is the modifier. If you want to restrict access to the class, you can define a modifier as public or private. Then we use class keyword to declare a class and the class name. Then if you want to use inheritance, you can use extends keyword with class name. And if you want to implement an interface, you can use implements keyword with interface name. So once you define the class, in the body of the class, you can define member variables and methods of the class. In order to define member variables, we have to define a modifier, which is also a public or private. We need to define the data type for the member variable, such as the int or string, and then variable name based on naming rules. And then we can assign a value to the member variable. So using person example, we can say each person has a name and has an age. So private string name mean that the person, the variable name is data type is string and the variable is private, cannot be accessed outside the class. Similarly, we have age. So age can only be an integer number. So data type of age variable is integer, and the value we assign in this example is 20h. Now we learn how we can declare member methods of the class. So first we need to define the modifier to restrict access to the member method. Then a method can have return type or method can be void. So if there is no return type of a method, we can just use void keyword. Then we give the method name, and in the parentheses we can provide different parameters, which can first we define parameter type such as int or string, and then we can provide parameter range. In the body of member method, we can define our functionality, and then if the return type of a method is integer, then we have to return int value at the end of uh, the body of the member method. After declaring member variables and member methods of the class, we are able to create an object of the class. So to create an object, first we need to define the class name and the object name. And to initialize object, we use new keyword with class name. So in example, we have a person, object P, and to initialize, we use new person with the equal sign. So there are different types of member variables. For example, for byte, int, and short member value type, we can initialize value with the 0. For double and float, we can provide initial value as a precision. We also have Boolean, which means that we can provide true or false value to a member variable. So there are different kind of member variables with data types we can use in Java. So we can also restrict the access control of variables, function, and classes in Java using 4 types of access control, which is private, default, protected, and public. Each modifier have different access scope. For example, if a member variable or member method is a private, it can only be accessed within the class itself. By default, you can access member variable inside the class and inside the same package. If you want to access a member variable or method within subclasses, you can use the protected access level. And lastly, for the global scope, we can use public as a access modifier in Java. Let's talk about encapsulation in Java. So to understand the need for encapsulation, we can take this example in which we create an object of the person as P, and we are going to assign value to the member variable name and member variable age. In this code example, you can see we assign -18 value to the age. When we execute this program, it will not generate any error because -18 is an integer value. But in real life, it's very unrealistic because age cannot be negative in real life. So to solve unrealistic situations, Java allow us to restrict access to the member variables. So restricting access to the member variables, and then we can use some public methods to give access. This type of behavior or this type of coding is called encapsulation. So to achieve encapsulation, like in this example, first we need to make our class members or class attributes private. So let's say we have a person age which is a private integer and cannot be accessed outside the class. So we make 2 public methods for this attribute. The first method is get age, which means it will return the value behind the age member variable. The second one is the set age, which means if you want to assign a value to the member variable, you can use the set age function. So this is how we can achieve encapsulation in Java programming. So assume a scenario for method overloading that you need to implement a method that can add 2 numbers or maybe more than 2 numbers in a program. So each number have their own uncertain data types. For example, a number can be an integer number and a number can be a float or double number which have a precision value. So you want to use a different data types for same method, we can use method overloading in Java. So in this way, we can use same name for two methods, but we can provide different types or different set of parameters. So this type of programming is called method overloading. So in this example, you can see we have a class sum and which have a method add numbers. So numbers can be integers, number can be precision values such as double. So we provide two methods. Now if we want to call the first method, we only need to give integer numbers. So if the input variables are integer number, the first method will be invoked. And if the parameters are in precision, the second method will be invoked by Java program. So this is the basic format for the constructor method. In constructor method, we need to meet three conditions. The first condition is the method name should be same as the class name. So this is the first rule. In the second rule, there should be no return statement. Since constructor methods are designed to initialize the class objects, so they cannot be used like regular methods where we have a return value. So by default, the Java program called no argument constructor whenever we initialize a class objects. For example, you can see here that we have a class person. So in when we create this class, the Java program will treat this class as a no argument constructor. So this code is equal to providing no argument constructor by default in Java. But if you provide some custom constructor which have input parameters, so these constructor can be override while creating the object. Now, why we use this keyword in Java? In some scenarios, when we have to access the member variable and the local variable, but both variable have same name. So to differentiate between local variable and the member variable, in Java, we can use these keywords. For example, we have a person and the variable is age. In the constructor method, we are trying to assign a parameter age value to the member variable age. So to access the member variable or to differentiate between local variable and member variable, we can use this keyword. So this dot age means we are accessing member variable age, and then equal to age means we are assigning the input variable age to the variable member variable in this program. We can also call a constructor in Java using these keywords. For example, if we add this with brackets in constructor, we are actually calling the default no parameter constructor. So if you want to provide parameter, we can also use this keyword and provide parameters according to the member variables in the parentheses. Let's go to the final example. In this example, we are trying to cover the 5 concepts we study in this presentation. So to implement the final example, we take the same class, the person, and we define 3 variables. So the person is the name of the class, and we have 2 string variables and 1 integer variable, and we set all variable as a private. After creating class, we need to access the private member variables, so we define some public methods. For example, set name will set the value of first name, and get name will return the value of first name and last name. And lastly, to display all the information of the member variables, we use display info, which indirectly access the person info using a public method. Then we try to overload set name method with different number of parameters. So in this overloading, we are actually providing one parameter and two parameter. So in first example, we only provide the first name because some people have only first name and no last name. So if a person have a last name and we provide two parameters, first name and last name, the second method will be overloaded by Java program. We can also add constructor, and we can also initialize the constructor and overload constructor methods. So in this example, we define three constructor for person class. In the first constructor, we give the default values, which is empty string for string values and 0 for integer values. And in second constructor, we provide two parameters, the first name and the age. And in the third constructor, we provide three parameters, first name, last name, and the age. Once we define and our class, then we can use a public static void main function to create an object and invoke the functions provided behind the person class. So in the first, we create object using the default constructor. In the second, we create object with the two parameter constructor. And in the third, we create object with three parameter constructor. So when we call the display info function, each function will display different information. So to demonstrate this example, we use we use the Eclipse IDE, which is an open source IDE. You can install this IDE, which also have built-in JRE for Windows. So once you install, you can create a new project with the person, and then you can add person class in the source file. So in this example, you can see here that we have three parameters. We have the no argument constructor, we have two argument constructor, we have three arguments constructor. Then we have methods, set name, and then we overload this method by providing two parameters. And then we have the display info function. Now let's execute this program using run.java class. So once we execute this program run as Java application, you can see here, because in the first constructor we use no argument, so the value is default, which is empty name and 0 age. For the second one, we assign the first name and the age, so we display second person info as Bob and 25 age. And in the last one, we use three parameter constructor. So in this last object, you can see we have the name as Alice Johnson and the age is 30. So this is a way to design and define methods in Java classes, and then we can overload methods by providing different set of parameters. So this is the end of today's presentation, and I hope you like it. I will also add the program within the description of this video so you can practice